Okay, so this video is going to go over the concept of equilibrium. So equilibrium is when x dot is in a state space model is equal to 0. And it is generally referred to as rest, though that's not always necessarily true. A mass can be moving and still be at equilibrium in some cases. So rest is usually referred to equilibrium, but it's not necessarily uh, what its standard definition would be. Now, note that equilibrium doesn't always exist, not for every system. Not every system has an equilibrium. Now, if we have a state space model, how can we find the equilibrium? Well, our state space model's x vector dot is equal to our nonlinear functions depending on x and u. We're going to remove our time variable here for sake of simplicity. And then all we're going to do with our state space equation is we're going to set that x dot is equal to 0. Our equilibrium terms are going to be x vector e and u vector e. So x vector e is our states at equilibrium values. U vector e is our inputs at equilibrium values. Sometimes we can actually decide what those are. And then y vector e is our outputs. Those are our outputs at equilibrium. And sometimes you can represent these using x bar, u bar, y bar, etc. to represent those equilibrium points instead. I'm going to use E a lot of times. So all you need to do is solve this first equation here for those x vectors, assuming that that x vector at equilibrium, assuming that you know what u vector at equilibrium can be, or maybe vice versa. And then you can figure out what your outputs at equilibrium would be, y vector E. And that is going to cover equilibrium.